So we're going to convert the polar into rectangular or the rectangular into polar. And so if you look at this one, everybody go to 37. And once you see these, we didn't get a chance to go over this on Friday, but you're going to see that this is really easy. We're going to, let's draw a picture. This is over 0, up 5. Okay? This is over 0, up 5. What angle is this? What angle is that in radians? Pi over 2. So theta is pi over 2, and r is how far from the center is it? It's 5, isn't it? So this coordinate is 5 comma pi over 2. Now that's not so bad. Gabby, if you could help us here, that'd be great. Once we get over here, though, and we draw this one, and we go over 3 up square root of 3, you know, that's kind of challenging, isn't it? But not for us, because we know a little bit about triangles. Okay? It always comes down to triangles, isn't it? This whole semester? Triangle, triangle, triangle. We're going to go over 3 and up square root of 3. Now, with that knowledge, can you find this hypotenuse and this angle? The hypotenuse is called r, and the angle is theta. R is easy. It is the square root of x squared plus y squared. It's the Pythagorean theorem, our best friend. 9 plus 3, square root of 12. Now, for the angle, what relationship is there between square root of 3 and 3? Sine, cosine, or tangent? Tangent. The tangent inverse of square root of 3 over 3. Take out your calculators and go inverse tangent. Let's start with the degree mode today, because angles are easy to recognize. If you took the inverse tangent of square root of 3 over 3, which angle do you get? I'm going to tell you it's either 0, 30, 45, 60, or 90. It's one of those. Any gutsy feels? You think it's 30? Okay. Try it. Did you get 30? Yep. And the reason it's 30 is the square root of 3 over 3 is like the square root of 3 over root of 3 root of 3. So those will cancel out to get 1 over the square root of 3. And I had this nice little chart that you're starting to get used to. Inverse tangent of 1 over the square root of 3 is 30, or pi over 6. What is it for square root of 3? Pi over 3. So it's going to be one of those. When you see a square root of 3 inverse tan, it's going to be either 30 or 60. The little one, 1 over square root of 3, is 30, or pi over 6. So this is theta. Well, here, let's do it this way. R theta is square root of 12, comma, pi over 6. How are we doing? Doing okay? You try this for 39 and 40. Good luck. So for this next one, let's use our formulas. Let's use the formulas for this one. R is the square root of x squared plus y squared. So when I find R, it's going to be 7 squared plus negative 7 squared. Isn't that just going to be square root of 98? Yeah. Okay, love it. Now, theta is the inverse tangent of y over x. So that is the inverse tangent of negative 7 over 7, which is, what's the inverse tangent of negative 1? Well, I'm going to help you with that a bit. What you're going to do there is Okay. Move that over a bit. On a circle here, here's -1 inverse tangent. What angle is this? Let's look at the beginning here. 7, it's over 7, down 7. Oop, guess I picked the wrong one. It's going to be down here. So that's the inverse tangent. What angle is this? You can go either way. 7 pi over 4. Or you could say negative pi over 4. Okay? So our answer for this one is going to be square root of 98, or 7 square root of 2, comma, negative pi over 4. Or you could say 7 square root of 2, 7 pi over 4, or square root of 98, 7 pi over 4. How many had something like this? Any questions on that one? You done, Emma? Fill that out, and I'll sign it for you. Okay, last one. Here's my x, and here's my y. If you want to draw a picture of it, it's going to be -3 down square root of 3. It's going to be something like this. So here's my triangle, theta. R is the square root of -3 squared is 9. Negative square root of 3 squared is 3. That'll be square root of 12. And then the theta is the inverse tangent of y, negative square root of 3 over -3. There you go. Okay. And so this is going to be -3, negative square root of 3. Is that right? No, I got it backwards. So y is negative square root of 3, and this is -3. There you go. So when I did that, is this going to be, did you get negative pi over 6? I think. Or no, this is just going to be pi over 6. And so this, I think, angles pi over 6, which is going to be 7 pi over 6. So my answer is going to be square root of 12, and then 7 pi over 6. Anybody get that? That's a tough one. So in review, when you have r theta, and you're starting with xy, and you're converting to r theta, what you're going to do is r is the square root of x squared plus y squared. And theta is equal to the inverse tangent of y over x. Good? That's just from the triangle. Old news, easy as can be. It's old right triangle knowledge. Now, zip on over to, we'll come back to that. Oh, I had this all over here. Now, let's say we wanted to go from polar to rectangular form. Now, this one's kind of interesting. You have it in r theta form, and you want to find x and y. Well, what's the relationship between these three? Turn to your neighbor. Tell them what that. All right. So, Owen, tell me that relationship between these three. Of r theta or x, cosine of theta is perfect. Is that all right? I mean, it seems almost too easy now, doesn't it? Now cross multiply, and now you're going to get r times the cosine of theta is going to be equal to x. So whenever we see x, it's r cosine theta. What do you think it's going to be when we're looking for a relationship between these three? What's that going to be? Sine theta, which is opposite over hypotenuse, which of course cross multiply is r times sine theta, equal to y. So y is r sine theta. The only four formulas you need to know is this one, and those two for this chapter. And we're going to be converting back and forth between these, and this is where it gets good. That's where it gets interesting. We'll come back to this. This isn't too bad. Let's say that we wanted to convert equations into other equations. So let's start with, this one's kind of tough. Let's start with this one, y equal negative x. And we want to convert this into polar. Well, we said y was r sine theta. What was x again? R, what's that? Cosine theta. Yep. Okay. Anything cancel out? Anything cancel out? The r's, yep. And so you're going to get sine theta equal to negative 1 times the cosine of theta. And we're going to try to solve this for one angle. So we're going to divide both sides by cosine. Like that. What is sine over cosine? It's the tangent. So the tangent of theta is equal to what? Negative 1. This formula here is the same as this in a polar form. And if you want to, you could solve for theta inverse tangent of negative 1. In fact, let's do that. Let's do that. You got this part. That's good. Well, let's keep going here. So theta is the undoing tangent of negative 1. And what is the inverse tangent of negative 1? Where is that where the tangent is negative 1? What angle is this? Negative pi over 4. That's your actual answer right there. That's these two are equivalent, which is pretty awesome. You try C. Go ahead and try that one. See how you did. So y is r times the sine of theta. But what was x? R times what? Cosine of theta. And then what happens there is that this one's going to be squared. So this one's going to be a little different. R sine theta is equal to r squared cosine squared theta. And so we'll lose one of those, leaving r cosine squared theta equals sine theta. Remember how you were really annoyed about those identities, doing those identity problems? But you're going to be doing that all the time this semester, the rest of this quarter. Like right now, we're going to divide both sides by cosine squared. So we can cancel those out. R is going to be equal to sine theta over cosine theta and 1 over cosine theta, because this cosine squared is still intact. Well, what's sine theta over cosine theta? What is that? Tangent of theta. And what is 1 over cosine? Snake? No. Secant. There you go. Secant of theta. And this is the equation for a parabola in polar form. Do you believe me? Good. Oh, I appreciate that. But just in case you don't, let's try this. Take your calculators out. Zip on down to calculator. We're going to graph both of these in polar form. And I don't think I can graph this one with your calculators. But this is easy because it just says that all the thetas are negative pi over 4. Okay, any r you put in, and that's what the line's going to be, which is y equals negative x. That one makes sense. This one, we're going to have to graph it to see. Ooh, I turned around and I just about ran over you. Great. Excuse me. All right, in your calculators, go to, let's see, polar. I'm not there yet. You're welcome. Polar, and we'll enter. And then when I do that, you'll get y equals will be r's now instead of y's. And we're going to put tangent theta, and the calculator doesn't have secant, so we're just going to divide by cosine theta. Okay. And when I graph it, it should look very parabolic. You ready? This is so exciting. What just happened there? I think I know what it is. I'm in radian, I'm in polar, I'm in, sometimes you have to turn off your plot to graph these. I think I'm okay. Oop, zoom 6. That's not, I didn't type in y equal x squared. I typed in tangent theta over cosine theta. And it is a perfect parabola graph. All right. This one's a little nasty, but I'll let you try this one on your own. This is a good little challenger. It's going to be a circle, but, oh, let's do it because it's kind of fun, actually. Let's do this one. Doesn't take long. Okay, for this one, you have x is r cosine theta minus 3 squared plus y squared, which is r squared sine squared, equal 9. Okay, so this is going to be r squared cosine squared theta minus 3r minus another 3r will be 6r cosine theta. Oh, this looks bad. Plus 9 plus r squared sine squared theta equals 9. Uh-oh. Oh, what happens to the 9s? They're out. Cool. And let's put these two together. R squared cosine squared theta plus r squared sine squared together minus 6r, I'm going to move it to the other side, equals 6r cosine theta. And just do me a little favor. Would you come up with a method of simplifying this? Let's do this first. Take out an r squared. And what is cosine squared plus sine squared? 1, right? So since this thing goes to 1, I'm going to get r squared equals 6 times r times the cosine of theta. And what can you divide both sides by? R. So you're going to get your answer, 6 cosine theta. And that should get you this shape. Let's take our calculators and check it out. Let's see what 6 cosine theta looks like. It's an ellipse, and it's shoved over. The center is shoved over, it looks like 3. To the right, 3, up 0. Oh, it disappeared. There it is. It's moved over 3. There it is. Okay, so last thing, very, very last thing, is we're going to go the other way. Now we're going to use the rectangular ones. We're going to use r equals the square root of x squared plus y squared, and theta is the inverse tangent of y over x. We're going to substitute those in here. So like this one's easy. Square root of x squared plus y squared equals, that's what r is, -3. I want to solve for x squared and y squared. Let's square both sides. So you get x squared plus y squared equals what? Careful. What's -3 squared? Huh? 9, yeah. Isn't this just a circle? Center, origin, out 3? Yeah. Isn't this r equal -3, just a circle, radius 3? Yeah, the negative just means you start on the opposite side, but it's still a plain old circle. Theta, easy. Inverse tangent, y over x is equal to 4 pi over 3. Take the tangent of both sides. And you're going to get y over x equals the tangent of 4 pi over 3. Now this one you're going to have to do a little thinking on. Unit circle time. 4 pi over 3 is right here. That's going to either be 1 over the square root of 3 or the square root of 3. Which one is it? Down here. Further from here. It's going to be square root of 3. So y over x equals the square root of 3. So y is equal to the square root of 3x. I'm not kidding you. This is the same as that. Then last but not least, r, which is the square root of x squared plus y squared, is equal to 1 minus the cosine of theta, which is the inverse tangent of y over x. Now somewhere, sometime, somebody should have taught you how to take the cosine of a inverse in parentheses. Someone should have told you what you do when you have an inverse in parentheses and then take the cosine. Did anybody tell you that? Did it teach you a song or something? Yeah, there you go. That's the Make a Triangle song, right? Make a triangle. There you go. And so when I make a triangle and I use tangent, it's going to be y over x. What will this be here? Square root of x squared plus y squared, right? So if I'm taking the cosine of this, it's going to be x over that. So you have the square root of x squared plus y squared is equal to 1 minus cosine x over square root of x squared plus y squared. Did I go too fast on that? Okay, cosine of this triangle. We made the triangle here. Then we took the cosine, adjacent over hypotenuse. Now I'm going to take all of this out of your way because it's cluttering my view. You're doing very well, by the way. And now what we could do is square both sides. Ugh, I don't want to do that. I think I'm fine just the way it is. Just leave it that way. It's in terms of x and y, right? Ta-da, done. All right, for homework. For homework, what you're going to do is you're going to, again, find the 4 different answers. And then you're going to do some more converting. You're going to convert this which is in r theta, and you're going to convert it into x and y for all of those. This one also is in r theta, and you're going to find your x and your y. And I'm going to help you just a little bit with this one. X equation is r cosine theta, and y equation is r sine theta. Do you remember that? This is r, and this is theta. So we're going to plunk in, for r, I'm going to put in a 13. Cosine times the cosine. What is theta? Arc tangent of 12 over 5. This is math on the moon. You've never done that, the cosine of the arctangent of 12 over 5. You've never taken the cosine of, wait, we just did a couple minutes ago. What do you have to do? Make a triangle. And you'll do the same thing here, except it's going to be the sine of the arctangent of 12 over 5. Do you see why I like this chapter? It keeps bringing back things from the past. And then these you're going to convert into r thetas. And then these you're going to convert into x and y's. And we'll let you do those for tomorrow.